Chris. How are you doing today?
I'm good. How are you?
Good. Let me turn the sound down on this thing over here. All right. Back to factoring. I realize there's one kind of factoring we haven't talked about. It's as easy as greatest common factor, if not easier. And it's an equation, basically, if you have this, it's not really factoring, but it is. How would you solve that equation? How do you get just x? Well, let's experiment. I could divide both sides by x. That would truly give me x on the left, but notice that it gives me x on the right also, which means that's not an answer. In other words, you not only want to get x on the left, you want to get nothing but numbers on the right. So that's not going to work. How else could we turn this x squared into x?
We can do the thing where we separate it into two parentheses, so it'd be x, and then it'd be...
Well, you actually are on to something there, but I'm going to point out what the easiest way to do this is. And that's to take the square root of both sides. In other words, if I take the square root of x squared, I'm going to get x. Now, here's the tricky part. The tricky part is if I take the square root of 25, what is it?
5.
Well, it's actually plus or minus. And the plus or minus 5 is extremely important because I actually do have two solutions. Both of them work. In other words, if I go back to my original equation and plug in minus 5, well, minus 5 squared is equal to 25, as plus 5 squared is also. So I definitely have two solutions, x equals plus 5 and x equals minus 5. And this is one of the hardest things in the world for people to remember. And the thing I keep telling people, it's not very effective, I don't know of a different way, but whenever you are taking the square root of both sides of an equation, then begin your answer with plus or minus. I wish I had a song I could teach you, because I guarantee you'll make that mistake lots of times. I make it myself, but about 95% of my students make it. They leave out the plus or minus. Now, another way of doing this problem is I could subtract 25 from both sides, right? And now we can do what you were talking about. What is this thing called on the left?
X squared.
Dopes. What does dopes stand for?
Oh, yeah.
Difference of perfect squares. That's a perfect square. That's a perfect square. And there's the difference of them right there. Okay? So, if I'm factoring this as a difference of perfect squares, what does it factor into? And this looks like what you wanted to do in the first place.
Yeah. It's x on both sides and then a minus.
You know what? When we're doing difference of perfect squares, we do it a little differently than a normal quadratic. I don't even do that as my first step. My first step is to figure out everything on the left side, because I know the right side is going to be easy. It's just going to be the same thing with the opposite sign, right? In other words, all my work is done in this left parentheses. Well, what goes here after the minus sign?
5.
And now I automatically know the other side is x plus 5. And notice that gives me two solutions also. If I set that equal to 0, I get x equal 5. And if I set that equal to 0, I get x equal minus 5. So regardless of how you do it, you're going to still get those two solutions. It's actually a little bit easier to do it this way. In other words, you don't really have to do much. Let's take a slightly more complicated problem. Now, how am I going to do this? This doesn't work quite so well for dopes because I suppose you could say that you could use it, but the most logical way to do this is the way we did the first problem last time, which is to take the square root of both sides. So what do you get when you take the square root of the left side? In other words, when I take square root of both sides, I'm doing this. Okay? What's the left side give you? What do you get when you take the square root of this quantity squared? You always get whatever is in the parentheses. Okay, so you always get x minus 2. But remember, it's equal to plus or minus 5. And our goal is to solve the whole problem. So what's the next step? I'm trying to solve for x.
So you would add 2 to both sides?
Okay, so here's what that looks like. Plus or minus 5 plus 2. Now what are my two answers for x?
X equals 7. And x equals 3? No.
A minus 5 added to a plus 2.
Oh, minus 3.
There you go. And there's your two solutions. And notice that wouldn't have come quite so easily if we would have tried difference of perfect squares. I guess it actually would have been okay, but this is the way you want to solve those problems. This is kind of the fourth technique for factoring. Okay? All right, still more factoring, but now we're going to factor for the purpose of simplification. In other words, what if I had this problem? What's the answer?
X equals 9.
Not 9. 9 times 9 is not 18.
Yeah, it equals 8, sorry.
It's equal to, the first words out of your mouth should be plus or minus the square root of 18.
Yeah.
In other words, that's all I did. 18 is not a perfect square number. So I'm not going to translate that to a decimal. I want to leave it in rational format, which is what you tend to do when you get to algebra. Sometimes they'll have you convert it to a decimal, but it's a better number written this way. It's totally precise when I write it square root of 18. Whereas if I put that into a calculator and put down a number, I've got to round it off at some point. I don't have a precise number anymore.
Yeah.
Now, the problem is that now our job is to simplify that. That is not a proper way to answer the problem because I can write it as a product of a whole number and another radical number. Now, here's the two rules you have to remember. If I'm taking the square root of two numbers multiplied together, that's the square root of the first times the square root of the second. In other words, if I want the square root of 2 times 3, which would be 6, that would be the square root of 2 times the square root of 3. Okay? Simple enough?
Yeah.
The other half of that is the division part. If I'm taking the square root of a over b, that's the square root of a divided by the square root of b. Same thing, essentially. Same principle at play. So, square root of 18 can be written as square root of 9 times the square root of 2. And that's important because this is a perfect square number, and I can turn it into a 3, which is still exact. I haven't approximated it at all. So square root of 18 actually becomes square root, or 3 square roots of 2, and you still have the plus or minus. Now, let's talk about this for a second. If I write the square root of 9, that is equal to plus 3. With me?
Yeah.
It's only if I am taking both sides of an equation where if I have that as an equation and I write the square root of both sides, the square root of 9 is really plus or minus 3. The reason we write that as plus 3 is the same reason that if you write any number without a sign in front of it, it's presumed to be plus. If I want the minus answer, I would write it like this. Minus the square root of 9 would be minus 3. Okay, so in terms of terminology, when you see that, it always means plus. But when you have to take the square root to solve an equation, you have to include both plus and minus. Okay, so what we're going to do next is let you simplify some of these. Because like I said, if you're going to definitely have this in Algebra 1 where you have to simplify this. Now, I always want to turn this, you know what, let's take a different one. Let's do 40. Okay? Now, I could separate 40 into the square root of 20 times the square root of 2. But I'm not going to do it that way because the square root of 20 is not a perfect square number, nor is the square root of 2. I always want to look for factors where one of them is a perfect square number. Well, in this case, that's 4 and 10. And then this I can turn into a 2. The rest I can't do anything with. While it is true that the square root of 10 is equal to the square root of 2 times the square root of 5, that is not considered simplification. I've taken the square root of a single term and I now have the square root of 2 terms. So we don't reduce unless we can find a factor that is a perfect square number. That's kind of the definition of reducing. Now, over here on the right, I'm going to write perfect square numbers. This is a list of numbers you want to get familiar with. What's next? This is 2 squared. This is 3 squared. What's next is 4 squared. What is 4 squared?
Yep.
What'd you say?
4 squared is 2.
4 squared is 4 times 4.
Yeah, sorry.
What is it? 16. Okay, what's 5 squared?
25.
6 squared?
36.
You're not doing these on a calculator, are you?
No.
Okay. Because if you are, we want to go back to A+. This is vital that you do all of this work not on a calculator. There will be problems where we'll want you to use a calculator, but for our purposes and getting your foundation of math strong, we want to make sure you're not using a calculator for this. But keep these numbers in mind. Those are the numbers we're looking for. So, let's simplify square root of 48. In other words, if we can't find any factors that are in this list, then it's simplified, and we're done. Yeah. Is 48 divisible by any of those numbers? I should say evenly divisible. It's divisible by 4.
Yeah, that'd be 12.
Okay, so that would be the square root of 4 times the square root of 12, which would be 2 root 12. There's a problem, though. The square root of 12 is also not simplified. Why? Because it's also divisible by 4. So, let's keep going. That's 2 root 4 times root 3. That's what the square root of 12 turned into. And now we have 2 times root 3. So our final answer is 4 root 3, multiplying the 2's. Okay, that was 1, 2, 3, 4, 5 steps. Well, that's okay. It doesn't really matter how many steps it takes you to get it. But notice that had I noticed in the beginning that 48 was also divisible by 16, another number on our list, 3 times, now I get to the answer in 2 steps instead of 4. So, when you're simplifying these radicals, it's always better to find the biggest number on the list that is one of the factors. But it does have to be a perfect square number. Now, I only wrote the first 5 of these because that's generally all you have to do. In other words, notice that on 48, there's no way it's divisible by 25 or 36. They're more than half. So it can't be divisible by either of those numbers. And it's rare that you ever have to even deal with 7 squared or 8 squared or 9 squared. Sometimes you have to deal with 10 squared. Okay. What's the square root of 10? Or, excuse me, the square root of 100? My apologies.
Oh, 100?
Uh-huh.
That would be 10 times.
Okay. So, what's the square root of 200?
20 times.
Separate it into 2 numbers. In other words, find factors of 200, one of which is a perfect square. There's a lot of numbers on here that work. That divides into 200. This divides into 200. But what's the biggest number on that list that divides into 200? We just did it the step before.
100.
So it's the square root of 100 times the square root of 2. These two numbers still have to multiply to this number, but now I can turn that into a 10 root 2. Okay, so occasionally you'll be given problems that'll have numbers higher up, but in general it's those 6 or 5 that you have to pay attention to and know. It's pretty much like you just have to almost memorize these 5 numbers and say, oh, that's my perfect square list number. Okay, let's do another one. Notice that this is also all about factoring. We can't get away from factoring. The way you solve these problems is by factoring. It's just that you're factoring a number. But that's just as hard to do as factoring a quadratic, factoring a number. What are factors of 27? One number being on that list. This is another reason it's so important to know your multiplication and division tables, because your calculator won't factor it for you.
Yeah.
Is it divisible by 4? The number has to be an even number to be divisible by 4, at a minimum. Okay, so no odd number is ever divisible by 4. About 9.
It doesn't do it perfectly, but...
Yes, it does. Notice that these two digits add to 9. If you have any number in the world that adds to 9, it's divisible by 9. This number right there is divisible by 9. How do I know? Because all 4 digits add up to 9. Doesn't matter what number you're looking at. 81, that's divisible by 9.
Yeah, I forgot about that.
So when you see a number like that, know that it's divisible by 9. What's the other part? How many times?
3.
So what's the final answer?
It would be 3 root 3.
You got it. All right, I have a book in front of me that has these, so I'm just going to pull them out of here. In other words, when you see a number like this, well, you don't have to check if it's divisible by anything beyond 25, right? If a number is more than half this number, it's not going to divide evenly into it. It's impossible. But, so check these 4 numbers right there. Do any of those divide into 52? All right, let's make sure you can do long division. Because A+ math doesn't really work with these kind of problems. I mean, it doesn't give you practice on them. If you're dividing 4 into 52, it's all about single digit stuff that you know how to do. You just have to remember the method. You divide 4 into the first number, that goes once. Multiply 1 times 4, it goes right there. Subtract 5 minus 4 to give you 1. Bring down to 2. Divide the 4 into the 12. 4 goes into 52 13 times. Okay. So that is the square root of 4. I always write this first because this is what's going to change when I condense it. So that becomes 2 root 13. Now, do we have to check 13 to see if it's simplifiable?
No.
Because it's prime.
Yeah.
If you find a prime number, it is not ever going to have any factors let alone one that is a perfect square. So the moment you run into a prime number, you know it's done. You know what? Hold on a minute. We only got 5 minutes. Let me just cover one other thing here. Let's do a few divisions. We're not done with this section. This is another thing you need to get good at. But I'm going to review you in all methods of factoring in our next session. We're just going to go through all 5 of them and make sure you remember how to do each one. And we'll just keep doing that until you get good at all 5 of them. Believe me, once you get good at all 5 of these factoring methods, that's going to be like a magic wand when you go into algebra class. You're going to be amazed at how far that will take you. Assuming you are good on A+ still. So what's my first step here? Always. What was the square root of A over B equal to?
Alright, so it's going to be root 1 and then root 2, or root 9.
Okay, that's first step. What's root 1 equal to?
Root 1 is equal to 1.
What's root 9 equal to?
3.
There's your answer.
Oh, that was easy.
Yeah, no, some of them are easy. They'll get harder.
Yeah, I mean, they probably feel like they're all harder.
Yeah, well, there's another thing that we haven't addressed yet, and that's when you have a radical in the denominator. Let's just do this one real quick. You don't need to actually write out step 1. What's the square root of 4?
2.
It's the square root of 49.
49.
That's it. 2/7. Over here on that list, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. What the square roots of each of those numbers are. I didn't put the first one, 1, because you don't ever use that one. You're not looking to divide by 1.
Yeah.
All right. One last thing let's just spend a few seconds on let's say I had an answer like that. Well, there's a problem with this answer. Mathematicians do not like dividing anything by irrational numbers. Okay? If you think about it, there's not a lot of meaning to it. You divide something, you're splitting it into a certain number of parts. Well, we don't know how many parts there are if this is an irrational number. So there's this rule in math that says you can't have irrational numbers in the denominator. Now, what are irrational numbers? Any radical that does not simplify. Any radical that does not simplify. That is not irrational because I can write it as a fraction. The definition of rational is you have to be able to write it as a fraction. Well, square root of 4/9 is rational because I can write that as 2/3. Okay? So the only thing that's irrational is if you cannot write it as a fraction. Pi is irrational. E is irrational. All these magic numbers in math tend to be irrational. This is very precise. It means 2 times 2, or whatever the square root of 2 is, times itself is going to equal 2. Well, we use a little trick here called rationalizing the denominator. And what you do is you can multiply any fraction by the number 1. In other words, I could multiply it by 3/3 if I wanted, because 3/3 is 1 and I'm not changing the value. As long as I multiply something by 1, I do not change its value. multiply or divide? Well, square root of 2 over square root of 2 is 1. And the result, when you multiply fractions, is you multiply numerators and you multiply denominators. What's square root of 2 times square root of 2?
2, or no 1.
No, you were right. Square root of x times square root of x is x. All right?
Yeah.
So, we always want to be multiplying the denominator by the same thing as what it is. That'll turn it from irrational to rational. Now, you might say, well, yeah, but we have an irrational number in the numerator. That's okay. Mathematicians do not mind irrational numbers in the numerator. They just don't like them in the denominator. So whenever you have one in the denominator, you've got to rationalize it. It's a fairly easy process. If I had 1 over root 3, I'm going to multiply that by root 3 over root 3, and you'll notice you get root 3 over 3. Well, 1 over root 5 would be root 5 over 5. It's not hard to do. Just got to be aware of it. You've got to be aware that we can't have an answer like this. If you had a multiple choice test, you're never going to see this answer. That's exactly the same number as this. Put both of them into a calculator, they'll give you the same answer. All right, good place to end. I will speak with you next Tuesday.
Yeah, and my grandma's going to email you about some stuff, like, I'm not going to be here for next August 4th. So.
Okay, so maybe a change in schedule, that's fine.
Yeah, she'll email you all the details.
Okay, sounds good. Talk to you later, Chris.